Hello friends and welcome to edupediaworld.com, your destination to online education. Friends, so far we have learned many interesting lessons and topics from defining matter to the atomic structure. Now in this session I am going to energize your knowledge on empirical formula and molecular formula. But friends, as this topic is a bit tricky and also is the basics of chemistry, I have divided the session into two parts, part 1 and part 2, where part 1 is the empirical formula and part 2 we are going to learn about molecular formula. So we will move one by one to learn and understand this topic more effectively. But before starting with the new topic, I want you to revise all the important terms which will be helpful for you to understand for the future slides. First is molecular mass. It is equal to the sum of atomic mass of all the atoms present in one molecule of the substance. Gram atomic mass, the amount of substance whose mass in grams is numerically equal to its atomic mass, which is gram atomic mass of that substance. Gram molecular mass, the molecular mass of the substance expressed in grams is called its gram molecular mass. What is a mole? 1 mole of atom, or you can say a particle, is equal to 6.023 into 10 to the power 23 atoms or particles. 1 mole of atom is also equal to gram atomic mass of the element. 1 mole of molecule is equal to the gram molecular mass of the substance. Students, if you want to learn more about mole concept, you can please refer to the mole concept video. So friends, let's start this session with concept of empirical formula. We'll be finding empirical formula of unknown compounds. We'll be having steps to find the empirical formula of the substance. Also, we'll be discussing few examples. But before, let me give you a brief idea about the chemical formulas. So friends, we all know now that matter consists of atoms, that matters are made of atom, and a group of matter or group of atom is called molecule, which are the group of similar kind of atom, right? So friends, here we have two kinds of molecule. We have molecule of element. We also have molecule of a compound, right? Molecule of an element, for example, is like H2, Cl2. That is, the molecule of an element contains two or more similar atoms. For example, a molecule of a hydrogen atom contains two hydrogen atoms and is written by H2. Similarly, we have chlorine, Cl2, containing two chlorine atoms. So both hydrogen molecule and chlorine molecule are diatomic molecule because they contain two atoms per molecule. We also have molecule of a compound, which will be containing two different types of atom, right? For example, we have HCl, we have H2O. The difference between these two molecules is they have the same atom. They have different types of atom joining together to form a molecule. So the different atoms and molecule have different property, due to which different matter also shows different property. So what do we call these molecule? We actually call them chemical formula. Now what is this? It is nothing but representation of the composition of a molecule of a substance, right? In terms of symbols of the element. The chemical formula is also sometimes called the molecular formula. Here we have understood the types of molecules which we have in the nature, and how do we represent the formula of element in the chemical formula, which is also important to know. So we write formula of element. How do we represent the formula of element? We represent by symbols and initial by numbers, right? For example, if I tell you we have H2, where H is the symbol of hydrogen, and this is the number of molecule. So that one molecule of hydrogen element contains two atoms of hydrogen, right? Similarly, we can also see the formula of compound. What is a compound? It is the combination of two or more element. That is, they are chemically joined together. So if I give you the example of compound, we have here a water molecule. So water is a compound whose molecule contains two atoms of hydrogen. These are two atoms of hydrogen and one atom of oxygen, right? So the formula of water is H2O. In the formula H2O, the symbol H2 indicates two atoms of hydrogen and O represent one atom of oxygen, right? What are these 2, 1? We know that they are the number of atoms of the element present in the compound. But just as an atom has an atomic mass, in the same way, a molecule has a molecular mass. Now let's come up to the important terms and definitions. Let's understand molecular mass. It is nothing but a relative mass of its molecule as compared with the mass of C12 atom. What does this mean? This means that the molecular mass of a substance indicates the number of times one molecule of a substance is heavier than 1/12 of the carbon atom, that is a C12 carbon atom. For example, if I tell you the molecular mass of hydrogen is 2, which means that a molecule of hydrogen is 2 times heavier than 1/12 of carbon 12 atom. That is, the hydrogen is 2 times heavier than the 1/12 of a carbon atom, right? You should also note that it is also called molecular weight, right? So how do you calculate the molecular weight? You just need to add up all the masses of the element to get a molecular mass of the particular compound. For example, let's calculate the molecular mass of the water. So what mass of hydrogen is 1. So mass of 2 hydrogen will be 2 into 1, which is 2. So mass of oxygen atom in this particular compound, which is water. So what will be the molecular mass of water? It will be sum of 2H atom plus mass of 1 oxygen atom, which will come out to be 2 plus 16, 18. So the molecular mass of water is 18. We can also say that molecular weight of a water is 18, right? So friends, let's understand why do we follow the symbolic rule, that is, why do we have a chemical formulas? What is the significance of the formula to, in chemistry and in the nature? As the formula represents the name of the substance, formula represents one molecule of the substance. Let's write down the significance of formula 1. Formula represents name of the substance. Secondly, formula represents one molecule of the substance, right? It also represents one mole of molecule of the substance. It also gives the number of atoms of each element present in the one molecule of the substance. Yes, it basically have many significance and advantages, as we can't write all the time hydrogen to oxygen. It will take more space, and also the symbols make you more understand about the topic or the about the composition of the compound more effectively. So we try to use more formulas than the proper names. As friends, everybody has their nicknames and the good names also. Why do we have a nickname? So that we can be called. As I have given you the definition of molecular mass or the molecular weight, we also have gram atomic mass and gram molecular mass, which is actually very important to know when we are talking about the empirical formula and molecular formula. So what are these? How do we calculate them? As if we talk about the gram atomic mass, so it is nothing but the amount of the substance whose mass in grams is numerically equal to its atomic mass, as the atomic mass of the substance expressed in grams is called a gram atomic mass. So to write the gram atomic mass of the substance, we write its atomic mass and then add the word grams. Or you can also add symbol G. For example, let's take the atomic mass of oxygen, which is 16. So what will be the gram atomic mass? It will be 16. We'll be adding only G. So it converts itself by gram atomic mass. Friends, gram atomic mass is also equal to the 1 mole of atom, which is equal to the 6.023 into 10 to the power 23 atoms, right? When we are talking about the element. And now if I talk about the gram molecular mass, it is as similar as gram atomic mass. Here we just convert the molecular mass to gram molecular mass just by adding grams to the molecular mass. For example, if I talk about O2 has the molecular mass 32, so the gram molecular mass will be 32 grams, which is actually similar to the gram atomic mass. It is also 1 mole of O2. I can say 6.023 into 10 to the power 23 molecule of O2. So if you want to learn more about mole concept, please refer to the mole concept video. You have a good idea about the important definitions. Let me start with the session with the concept of empirical formula. So friends, look at this image. We can see many raised hands. If I tell you to count number of heads present, what will you do? You'll first count all the hands, right? Then you'll divide total number of hands to 2. Why? Because we know the smallest possible ratio will be 1 head equal to 2 hands. That is 1:2, right? Similarly, let me give you a brief of the empirical formula. Friends, here we have empirical formula. We learned about the chemical formulae of element, how do we represent element, how do we represent compound, right? Let me give you now the concept of empirical formula. First of all, it is the lowest ratio of the elements present in the compound. Right? For example, I like to give you a very simple example, right? Let's suppose we are going to make tea. Let this tea be the compound, right? And what are the elements which will be present in the compound? It will be sugar, it will be milk, tea leaf, and it can be some ml of water. So let me keep A, B, C, D. So to prepare 1 cup, that is the minimal possible a person can prepare for 1 head, 1 person. We can write here 2. Milk we can write somehow half cup. Leaf, quarter teaspoon. Water you can take half cup. So it's 2. C will be 1/4. D will be 1/2. So to avoid this fraction, let me make multiply by 2 or 4 so that we can avoid the fractions. So it is 1, it will be 4. Let me do by 4 so that we can get a good whole number. It can be 2, C1, D2. So what is this we get? It is the lowest of the tea, that is for 1 person. If you have to prepare for 4, you can simply multiply by 4 and you can get the amount. You can get the actual quantity of tea. Similarly, it is just like empirical formula. That can be, we can represent this is an empirical formula, that is the lowest possible ratio of the elements which makes a compound, that is sugar, milk, leaf and water, that is A8, B2, C1, D2. This is the minimal possible ratio which we can use to form a minimum possible substance, right? So in terms of chemistry, let me give you more example. As we can take the example of here HO. This is a hydrogen peroxide. Do you think this is the actual formula? No, it is just the lowest possible ratio of two elements joining together to form a compound. This is the empirical formula. What is the actual number of hydrogen peroxide having? That is H2O2. So the empirical formula of hydrogen peroxide compound is HO. Let's write down. This is empirical formula. Repeatedly I am telling you it is the lowest possible ratio of two elements present in a compound, right? And this is the actual formula of hydrogen peroxide. So this empirical formula shows that in a hydrogen peroxide molecule the ratio of H and O is 1:1. It does not show the actual number of hydrogen and oxygen atom present in a molecule of hydrogen peroxide. See, on the other hand, you can see here the actual formula, which is also called the molecular formula and the chemical formula, which is actual H2O2. So this molecular formula shows that there are actually two hydrogen atoms and two oxygen atoms present in one molecule of hydrogen peroxide. Fine. So the relation between the molecular formula and empirical formula of compound is just, I gave you the example of tea. So relation is very similar to it. It is the molecular formula, which is also called the actual formula, is equal to the multiples of empirical formula. You can write here N to generalize this formula. So what is N? It's just a simple whole number, right? So friends, I hope now you have a good concept of empirical formula. What is it actually? So let's get the definition. Empirical formula of a compound is that formula which shows the simplest ratio of the number of different types of atom present in one molecule of the compound. For example, you can see here the chart. Hydrogen peroxide is HO, water is H2O, glucose is CH2O, but the actual formula is C6H12O6. Oxalic acid is HCO2, but the actual is H2C2O4. And similarly, you can see here ethanol, ethane, ethylene, and caffeine. Right? So now friends, let's go back and understand the next session, which is finding the empirical formula of unknown compound. Friends, to determine the formula of an unknown compound, what we have to do first, we have to do two things. First, we have to analyze qualitatively, then quantitatively. Let me try to make you understand. The empirical formula, what do we have to do? We have to go two steps. That is, we have qualitative analysis. Then in second we have quantitative analysis. So what do we do in the qualitative analysis? First of all, the compound is subjected to the qualitative analysis to know the various elements present in it. That is, we see the various elements present in it, right? Then what do we do then? We go to the quantitative analysis, where we have to find the mass percentage of each element present in the compound. So knowing the percentage of each element and their atomic masses of the compound, we can get a molecular formula also. So this is the analysis which we have to make to find the empirical formula. First qualitative, then quantitative. This is the summary which I have just given you, that first we have qualitative analysis to know all the elements present. Second is the quantitative analysis, where we have to find first the mass percentage and then the atomic numbers to find the empirical formula of a known compound. Let's get to the steps of empirical formula. How do we find the empirical formula of a compound, or you can also say the unknown compound? How do we calculate? Get a brief. Calculating empirical formula. Step 1. First, pretend that you have 100 grams sample of the compound, right? Second, that is, then we have to change the percentage amount to grams. Third step, then we convert the grams to mole for each element, right? Then we write the number of moles as a subscript in a chemical formula. Fifth, we then divide each number of element by the least number. Then lastly, we multiply the result to get rid of any fraction amount. Did you get these steps? No? So let me give you an example and make you understand about the empirical formula. Let's suppose we have to calculate the compound composed of 38.67% of carbon and 16.22% of hydrogen and 45.11 percentage of nitrogen. So actually what we have CHN. This is the actual element composition. We have to find the empirical formula for the particular chemical formula. So first what do we have to do? We have to assume it is 100 grams. So second, what we have to do? We have to convert it into moles. This is the grams. We convert it from percentage to grams. Convert percentage to grams. Then in this we convert grams to moles. So it is a carbon. 1 mole of carbon upon 12.01 gram. So what is the outcome? It will be 3.22 mole of carbon. Similarly, 16.22 grams of hydrogen into 1 mole of hydrogen upon 1.1001 grams of hydrogen, which gives 16.09 mole of hydrogen. Similarly, we calculate for the nitrogen, that is 45.11 grams of nitrogen with 1 mole of nitrogen upon 14.01 grams of nitrogen gives 3.219 mole of nitrogen. So now what do we get? We get 3 numbers. First 3.220 mole of carbon. Then we get 16.09 mole of hydrogen. We get 3.219 mole of nitrogen. So now what is the subscription? This is 3.22. Hydrogen gets 16.09. Nitrogen gets 3.219. So what would you do? We divide all of these by the smallest one. What is that? Which one do you feel and find the smallest? Do you find this is the smallest? Let's divide. One by one. So the ratio, so we can write here. So the ratio comes out to be is 3.220 mole carbon upon 3.219 mole of nitrogen, which gives 1 mole of carbon upon 1 mole of nitrogen. And the ratio of carbon and hydrogen C(H) is 5 mole of hydrogen upon 1 mole of nitrogen. So what is the empirical formula which we get? We get C1 H5N1, right? So this is the final empirical formula. I hope after following these steps you can also find yourself the empirical formula for many problems, numerical problem you can solve by yourself. Just follow these steps, these few steps, and you can get the appropriate answer. So you just have to find the lowest whole number ratio of, for example, C6H12O6. What is the lowest whole number? It can be 6. So divide by 6. You can get C1H2O1, right? Similarly, if we talk about CH4N, it is the only lowest whole number which is present. So this is the only empirical formula. So it is not just the ratio of an atom, it is also the ratio of moles of an atom. So in 1 mole of CO2 there is 1 mole of carbon and 2 moles of oxygen, and in 1 mole of molecule of carbon dioxide there is 1 atom of carbon and 2 atoms of oxygen. Always remember this. By these few steps you can also try out in your home, in your notebooks. You can also find many good problems. You can solve them. So let me give you more examples on the empirical formula if you're not satisfied with the one example. I again give you the example of hydrogen and carbon. If, for example, there's a gaseous compound which is unknown compound, we don't know that compound, but we know the composition, that carbon and hydrogen are there, where carbon is 75% and hydrogen respectively is 25%. What do we have to do in this step now? This compound contains only carbon and hydrogen, right? So this will be the proper composition. We just have now want to calculate the empirical formula so that we can make a lowest possible ratio of the elements present in the compound. So now the percentage of carbon atom is given as 75% and hydrogen, after minusing or by just taking in account that we have 100 grams of the compound, so we minus 75 from the 100 and get the amount of hydrogen, which is 25%. This is by mass, we can also call it, right? So let's solve it one by one. So first of all, we should convert mass percentage into moles of the atom by dividing the given percentage by the respective atomic masses. So first, mass percentage of carbon is 75 and atomic mass, we know that of carbon is 12. So what is the number of moles of carbon atom present? Just 75 upon 12, which comes out to be 6.25. And let's calculate for the hydrogen. is 25. So the atomic number of hydrogen is 1. So number of moles of hydrogen atom is 25 upon 1, which comes out to be 25 only. So now the ratio of moles of C and H atom in a compound will be 6 point is to 25. That is C is to H. So from this we conclude that for every 6.25 carbon atom there are 25 hydrogen atoms in a compound. So here the number of carbon atom in the fraction formula of a compound cannot remain fractional because only the whole number of atoms of various types is present in the compound. So we should convert the fractional number of carbon atom into the whole number of carbon atom. So we simplify this by dividing the smallest possible figure, which is 6.25, both sides. So what do we get? We get 1 is to 4. So now what is the final result? This shows that carbon, hydrogen, here it's 1 and here it's 4. So this is the empirical formula. This is the final empirical formula we get by calculating the masses of carbon and hydrogen. Yes. So it is basically a very simple and interesting calculation which can be very helpful for those who are looking forward for the competitive exams and also looking forward for higher education in chemistry, sciences. Let me now end up with this session. Let's meet the second part, the molecular formula, in next session. Thank you.